All right, guys. This is potentially our last lesson of the year. Sad. I know. I know. Try not to cry over it. You'll know more about the final on Monday. The final will not be on Monday, but you will know more about it then. Okay. So we're just gonna head right into it. This is just a continuation of our last lesson, chapter 12, part 3. The homework is like a very similar kind of like quote unquote worksheet. Same, it's essentially on the same page but different numbers. So make sure we check that out. So last time we focused on a permutation. If you remember permutation, order matters. When we're picking things, the order matters. Like who comes first, second, third. A selection of objects when order does not matter is called a combination. So when the order does not matter, we don't really care who comes first, second, or third, and so on. It's called a combination. This is the formula for a combination. Sometimes I write a combination like this. Okay. R is what you're picking. And N is how many things you have. If you have a calculator, your calculator will be able to compute this too. I read both of these as N choose R. Okay, N choose R. Okay, like I said, your calculator should compute this. Remember, a permutation, we don't really use a calculator for a permutation, right? Like, we can get away with just making slots, like making spaces and filling it in and using factorials or whatnot. But for combination, we really do have to use a formula. So, let's check it out. How many cards are there a way to choose 5 cards from a standard deck of cards? So we have 52, choose 5. Okay, it's 52, choose 5. Remember, this is the same thing as saying 52, C5 like that. And the formula for this is 52 factorial over 52 minus 5 factorial times 5 factorial. But like I said, we have a calculator for this. If you don't have a calculator on hand, it's all good. I'm pretty sure that that there's some sort of online calculator that would do this for you. I just don't know where you would find one, but I'm pretty sure that there is one. Okay, so 52, choose 5. So I got 2598960, and that's my answer. All right, I'm just using a calculator. Don't do any arithmetic. Just tell if you'd use permutation combination. How many 13 card hands could you be dealt from a deck of cards? The first one I would say is a combination. Just because it doesn't matter what order you get the cards, because the hands would still stay the same, if that makes sense, right? Like if you're playing, easier. Like if you're playing poker, and you get 2 pairs, it doesn't really matter. Like, is there a pair of kings that come first or a pair of aces that come first? It doesn't really matter, because at the end of the day, you have 2 pairs. So, by the same logic, when you're picking cards in general, unless it specifically says so, order doesn't matter. How many 3-turn combinations could a padlock have? This is a permutation. Because you're talking about combinations, right? It's like a password, right? The order of a password matters. The order of a combination matters. So that's a permutation. How many batting orders could a baseball manager create using 9 players? This is a permutation as well, because it would matter like who comes first, right? Who comes first and whatnot. How many 6-player volleyball squads could a coach put on the floor if there's 9 women on the team? I don't know much about volleyball. I'm assuming this is a combination. I'm assuming this is a combination because out of nine women, you pick six to put on the floor. I don't think the order in which you pick the six matter. Versus C, when you're talking about batting order, like Jim going before Bob is different from Bob going before Jim. When you're playing baseball, like batting orders in baseball matter. It's called a batting order, right? So order matters. All right, number 8, a county legislature consists 13 representatives, 8 Democrats and 5 Republicans. They are setting up a 4-person committee to study the proposal to build a new. How many different committees can be formed if the group will consist of 4 Republicans? All right, so part A, you have 4 Republicans. Right. How many different committees could be formed if the group consists of 4 Republicans? Well, if it's 4 Republicans, we have 5 Republicans to choose from, and we're just picking 4. So 5 choose 4, which I think it should be 5 off the top of my head, but I could be wrong. Dang, I am never wrong. I am so good at this. Order doesn't matter because, and I'm using combination because order doesn't matter because you're just picking them, right? Democrats, so same logic, 8 choose 4. This one I do not know off the top of my head. This is 70. So yeah, there it is. Pretty simple. Because it doesn't matter, getting picked first in a committee is not, it doesn't matter, right? As long as you get picked. All right, let's go into something a little bit more difficult. A rental store is running DVD grab bags. For $20, you can grab a bag containing 6 used DVDs randomly from 15 popular movies. The possible titles in the store ads include 4 comedies, 8 dramas, and 3 animated. If you buy one of the random goodie bag, what's the probability you get 2 comedies, 3 dramas, and 1 animated flick? Okay, so the bottom... So we're talking about probability, right? This is totally different. Because we're talking about probability, you have to set up a what we want over total, right? Remember, the top is want, the bottom is total. Total is always easiest, I feel like. So the total, right, is everything. What can anything happen? So the total would be 15 choose 6. Because in total we have 15 movies, and we're always getting 6 of them. Right, that 15 choose 6 accounts for every different type of combination of you picking movies, and the order doesn't matter in which you pick the movies, so that's why it's a combination. Now the top, what we want 2 comedies. So literally we want 2 comedies. Out of the 4 comedies, we're choosing 2. We want 3 dramas. Out of the 8 dramas, we're choosing 3. Out of the 3 animated pictures, we're picking 1. So the top, I'm literally now segmenting it into like partitions, like groups that I want, and I'm going to multiply all those combinations together. So let's check out what we have. 15 choose 6 is 5005. 4 choose 2. I should know this one off the top of my head. Of course I do. 4 choose 2 is 6, right? 8 choose 3 is 56. And then 3 choose 1 should be 3. Alright, I'm just pointing arrows to where they belong. So it's 5005 under 6 times 56 times 3. So 1008 is my final answer. So you have about like a 20% chance. Not bad. Moving on, you're playing poker and you want to find the probability of getting 3 kings and 2 fours, aka a full house. Okay, so playing poker, you need 5 cards in poker to play. So you got 52 because there's 50 cards in the deck and you're picking 5. Okay, you want 3 kings. Well, how many kings are in the deck? There's 4 of them, so 4 choose 3. Times how many 4s are in the deck? There's 4 4s in the deck, choose 2. So this is 4 times, God, I just did this one. 4, choose 2 is 6 over 52, choose 5. 2, 5, 9, 8, 9, 6, 0. So that's 24 over 2, 5, 9, 8, 9, 6, 0. We can probably reduce that, to be honest. Can this calculator reduce for me? No. Nope. Okay, so I don't know. I mean, it's fine if you don't reduce. No, I shouldn't say that. As a math teacher, I should not be saying that. So I get 12 over 1, 2, 9, 9, 4, 8, 0. I don't know. Let's try 2 again. 6 over 6, 4, 9. I'm just reducing at this point, guys. Let's go one more time. I don't know. Can this be divisible by 6? Oh, it can't be. So there's 1 over 108, 290. Cool. That's my probability of doing that. Super small. Next one. The DVD grab bags that we did before, 615. A. I want nothing but dramas. So I want all dramas. So once again, you're still picking 15 movies. You have 15 movies and you're choosing 6. But now I only want dramas. There are 8 dramas and I want all 6. So 8, choose 6. So that's 28 over 5,005. Right? Because I don't really care about anything else. I just care about dramas. That's why. B. 3 of the comedies and 3 of the dramas. So once again, the bottom is 15, choose 6. The top is I want 3 comedies. Well, there's 4 comedies altogether, so 4, choose 3. Times. I have 8 dramas, but I only want 3. 8 times 3, so that's 4, choose 3. So the bottom's 5,005. The top is 4 times 8, choose 3. Which is 56. So this is about 224 over 5,005. And then C is all 3 animated and then 3 other movies. Okay, so this one's pretty simple. The bottom is 15, choose 6 once again. Because remember, we have 15 movies in total. We want 6 from it. I want animated. I want animated movies. So the top is going to be 3, choose 3. Okay, and now I want any other movie, right? I literally want any other movie. So that means for animated, okay, you got to be careful. Any other movie, you only have 12 movies to pick from at that point. Because 3 are taken away because you used 3 for the animated. We're not going to include animated there because we've already used it. We want 3 from that section. So that's 5,005. 3, choose 3 is 1, so 1 times 12, choose 3. 220. So you get 220 over 5,005. So that reduces 4 over 91. And that's my answer. Okay, pretty simple. That was our last lesson of the year. Try not to shed a tear. Cool. All right, guys. Like I said, be on the lookout for updates on the final on Monday. Okay, this assignment's due on Monday, but look out for those updates. Okay, see you guys.